Okay, so a little introduction to some geometry terms. If I asked you to measure this angle, there's an angle here, and I'd like you to measure it. We would take our protractor, and the important thing here is how we set up the protractor correctly. We have to set up the protractor so that the point of the protractor is in line with where the two angles meet. So where these angles meet is where the middle point of my protractor goes. And then my protractor actually has to lie parallel to the line that I'm measuring from. And then I can go around and I can measure 0, 10, 20, 30, 40. And I can see here that I have exactly 42 degrees. But we can also see from the protractor that there's another scale going around here. What's that one doing? Well, it's actually giving me the other angle. If I wanted to measure this angle instead, I'd go around on the inner scale, 100, 130, 138 degrees. And you must use the degree sign, okay? That's very important. So what does that tell us then? The protractor as well shows us that all of the angles on a straight line add up to be 180 degrees. And that would make sense because we know that a full circle has 360 degrees. So if we went around from this angle all the way around to here, we'd have 360 degrees. So it would be reasonable that half of that on a straight line would be 180 degrees. Another important thing to remember about angles is that the angles of a triangle always add up. It doesn't matter which triangle you make. If you add up angle A and angle B and angle C, you will always get that they add up to be 180 degrees when you've drawn them properly with straight lines. Okay? So all angles of a triangle add up to be 180 degrees. And we have some different names for different angles that are important to remember. If I'm ever talking about an acute angle, it means I'm talking about an angle that is less than 90 degrees. And in Swedish we would call that... Yeah. And if I was talking about an angle that is greater than 90 degrees, I would be talking about an obtuse angle. And in Swedish you would call that? Yeah. And if I was talking about an angle that is exactly in the corner, means that that is a right angled triangle. So I might not write the number of degrees there, I would just put that little symbol there, and it means that is a 90-degree angle. Then we've got some names of different types of triangles as well. We've got this type of triangle, and we have this type of triangle. And we even have this type of triangle, and we have this type of triangle. What would you call this type of triangle? In Swedish? Yeah, and in English, almost the same. Right angled. Okay? Because it has 190-degree angle in it. What would we call this type of triangle? And we'd in geometry terms, we'd put a little line through here, and it means that these ones have the same length. What do we call this one in Swedish? Yeah. And this one has all the different sides the same length. What do we call that one? Yeah. So you need to know the names of your triangle because they might ask you to draw a right-angled triangle. And what would we call this one then? Yeah?
Rectangle.
Yeah. So we use the name of the angle that's in there because there's okay. So what else do we know about triangles? How would we work out the area of a triangle? If we would like to know So everybody understands what you need to know about angles now, yeah? How to use a protractor, how to measure an angle. If I was to draw a triangle, that looks like this, and let's say that this side is 10 centimeters and this side is 10 centimeters. And I would like to know what the area of this triangle is. How could we work out the area if this triangle had been a square instead? Yeah?
You take 10 times 10 divided by 2.
If it had been a square, the area would have been length times breadth, which would have been 10 times 10, which would have been 100 centimeters squared. But the area of a triangle, we can see that the area of the triangle would have been half of the area that it would have been if it had been a square. So the area of the square would be that. The area of the triangle would be the length times breadth divided by 2. And this is an important thing to remember. I see so many papers where you remember to multiply the length times the breadth of the triangle, and then you forget to divide it by 2. But then you're working out the area of the square. So whenever we're talking about areas of triangles, it's half the area that a square would have. What do you do then if you get a strange triangle? This is a nice easy one. It's easy to see that it's a square, yeah? What do you do if you have a triangle that looks a little bit more like half a rhomb? Or half a parallelogram? Let's take this triangle, for example. Here's my triangle, almost, and it's actually half of a parallelogram. Let's say that the length here is 15 centimeters, and that the vertical height here, so this would be the perpendicular height. If I dropped a 90-degree angle down from this point, and it met this base down here, and this height actually was 12. Now let's make it nice and easy. Let's make it 10. This perpendicular height here is 10. When we have a parallelogram, the important thing here is not how long this line is, it's what the perpendicular height is. So from the corner of the triangle, drop a 90-degree angle down. So the area of a triangle when we're working about rhombs and things like that is the perpendicular height, this sign means perpendicular, multiplied by the length of the base divided by 2. Let's say that this perpendicular height is 10. This one, would it be higher or lower than that? Higher. So let's say that this one is 13. And let's say that this one is 22. So if I was to work out the perimeter of my triangle, then these lengths are very important. This 22 plus this 13 added to the 15 would give me the perimeter of the outside of the triangle. But I don't use the 13 or the 22 at all when it comes to working out the area of the triangle. I have to use this perpendicular height. And the reason for that, it's almost like making this back into a square. You can think of it as being the same as a parallelogram. You use exactly the same formula for a parallelogram. You use the length of the base times the perpendicular height, this height here, from the middle of the parallelogram to the other edge, perpendicularly. So the length of the base times the perpendicular height gives you the area of a parallelogram. So the area of a triangle that can be made from a parallelogram uses the same formula. A perpendicular height times the base divided by 2 gives you the area of your triangle. And so this is very important when you're working out areas of triangles that do not have the right angle. And all of the questions that you'll be working with, they'll be giving you this height. Okay?